Hi guys, it's Ms. Griffin. We're taking a look at Unit 9, Skill 5, and in this skill we're going to be talking about density and population density. So your essential question is, how can we calculate density and population density? So you've been learning about density for a while in your science classes most likely, and so you should know this formula: density equals mass divided by volume. I'm going to be representing this with shorthand, just like some letters. D equals M over V. And you can remember this formula by the DMV. That's the place where you go to get like your car registration, your driving permit, your driving license. It's called the DMV. So D, density, equals mass divided by volume. And sometimes you can put this over 1 because depending on what you're solving for, you might want to eventually cross multiply. Just depends on the problem. So the density of a substance is a measure of how much mass is packed into a certain volume. That's why the density is equal to the mass divided by the volume. So we have a basic example here. It says, what is the density, so we're looking for D, in grams per milliliter cubed if carbon dioxide gas, or of carbon dioxide gas, if there's 0.196 grams. Now grams is a weight, so that's the mass. Mass is another term for weight. Occupies a volume of 100 milliliters, so this is the V. So we're looking for D, and we know the M goes over the V. So when we plug in, we have density equals the mass, 0.196, divided by the volume, 100. And I'm just going to put units on here for the first time, but I'm not going to put them on there after this. Because remember it said that in the end we want grams per milliliter cubed. This volume should actually say milliliters cubed over here. Please adjust that for me, because remember volume is always cubic. So we have grams per milliliter cubed. When we divide this, we get D equals 0.00196, and I don't believe it told us to round, so we're going to leave our answer just the way that it is. Now again, you do not need to attach units, but I just wanted to remind you that this grams per, where the dash means per, is the same as division, which is what we had going on here. Okay? Example 2, this is like a Common Core question. It's not the same exact one, but it was similar on an exam before. It says a rectangular prism is made of stone, and it has an edge length of 1.5 feet, a width of 0.5 feet, and a height of 0.375 feet, and a mass of 42.1875 pounds. So I'm going to put M here, because we know that that's definitely the mass. It says determine the density, so we're looking for D, of the rectangular stone to the nearest integer. P.S. Integer, it's come up a couple of times I believe, is just a whole number, so no decimals. So for part A, we need to find the density, but remember for density, we have D equals the M over V, mass over volume. They didn't tell us the volume in this problem at all, so first we have to find the volume. And it's a rectangular prism, so it looks like a tissue box, where we have a length of 1.5, a width of 0.5, and a height of 0.375. So when you have your reference sheet, you'll notice that this one is not on there. It is something you've been doing since like 7th grade. So length times width times height. That's going to be 1.5 times 0.5 times 0.375. Be careful when you type these decimals in your calculator, because just one slight little mishap in your calculator will screw the whole problem up. Okay, so when we type those in our calculator, we get volume equals 0.28125. So then the second step is to find the density. Let me just change my colors here. And again, this is all for part A, where D is equal to the mass, which we had 42.1875, divided by the volume, which was 0.28125. So now I'm typing that into my calculator. I know it's looking pretty messy, but Once you type it in, we should get a pretty nice number, which is 150. So I'm going to box that in because that's definitely an answer that we need here. That was for part A. And then for part B, the type of stone that the rectangular prism is made of using the density table, if the density comes out to be 150, then it must be made of concrete. So you just find the density in the table and then you match it with the type of stone. Okay, flip it over, we'll see another example. Example 4 says we have a lead ball with a mass of 420 grams. So I'm going to circle that and call it M. The density of the lead is 10.5 grams per cubic centimeter. So this is the D. What is the volume of the ball? So this is the V we're looking for. So I'm going to write up my formula first. D equals M over V, and I'm going to start plugging stuff in. I know the D, the density, is 10.5, so I have 10.5 equals the mass of 420 over the volume, which I don't know. And in this case, we're going to want to put this over 1 so that we can cross multiply. So you plug in what you know and you solve for what you don't have. Cross multiplying gives me 420 equals 10.5 V. Again, V stands for volume. If you don't like to put the V there, put an X in there. But it helps me to remember I'm looking for the volume if I keep the V. So now I'm just solving for V. I got to get it by itself, so I'm dividing. And when we divide 420 by 10.5, we get V equals 40. And again, you do not need to put units on this. Miss Wesley stressed that in the first couple of videos. If you put the wrong units on this, then we have to take off points. But if you don't put any units at all, then we can give you full credit. I know it seems backwards, but that's the truth of the matter. Example 5. Silver has a density of 10.5 grams per cubic centimeter, and gold has a density of 19.3 grams per cubic centimeter. So I'm going to circle those two in two different colors, though, because I have density of silver and density of gold, and I'm putting my D on both of them. Which would have the greater mass? So I'm looking for the mass of each. If we have 5 centimeters cubed of silver and 5 centimeters cubed of gold. So when we have cubic units, that's representing the volume. Same thing with this 5 centimeters cubed of gold. Justify your response. So I'm going to split my paper up into 3 little sections here. The first one's going to be for silver. The next one's going to be for gold. And the last one's going to be for my answer. Which one has the greater mass? So for silver, we're going to start calculating with D equals M over V. And again, we might want to put this over 1. Because we're not looking for the density, we're looking for the mass. So I'm going to start plugging in. Silver, I circled everything in red, so I know that we have 10.5 equals mass, which is unknown, divided by the volume, which was 5. So again, I'm going to put this over 1 and cross multiply to solve. So the mass is equal to whatever 10.5 times 5 is. So I want you to type that in your calculator real quick. You should be getting 52.5. And again, if you want to put units on this, this is grams, but I strongly suggest you don't put units on it. So silver weighs 52.5 grams. Now we're going to come over here and calculate gold. And I had everything for the gold circled in purple. So I know my density is 19.3, and it's equal to the mass, which is unknown, divided by the volume, which was 5 cubic centimeters. And again, I'm putting this over 1 so that we can cross multiply. Mass in this case is 19.3 times 5, so 96.5, and again it's grams. So now we got to decide which one weighs more, which has the greater mass. Well, clearly the gold is 96.5 grams, so answer is gold. You could write gold has the greater mass because if you want to, but it does not ask you to explain, so you're good to go. So that's regular density that you guys have been doing since 7th grade or 8th grade science. I don't really know which grade level you did it in, but you've been doing it for a while, D equals M over V. But now we're going to introduce a new type of density, and it's called population density. And if you think about population, it's the total amount of people or things or objects in a particular area. So you can see here on this little map that we can talk about the density of these maybe counties in this state by looking at how many people are in a certain amount of area. If there's a small area with a lot of people like we see down here, then we would say that this county is more dense than, say, this one with bigger area, less people. It's more dense if it has a larger number of population for every part of the area, per se. So we represent this in little letters as PD equals the population over the area. That's just me doing a funky A. Whoop, whoop. Okay, so it's like starting a star. I always use that for area. If you want to just do a regular A, then that's fine. It's up to you. So it's population over area. So we need to know some area formulas. Some of them are given on your reference sheet, but a couple of them are not. A square is not given. So a square, if you think about it, you have a length and a width. Oh, I just drew a rectangle. So we have a length and a width. So that means area of a square is length times width. A circle is on your reference sheet. See if you can find it real quick. You should have found pi r squared. A rectangle, again, has a length and a width, so this is L times W. Again, this is just area, so we're not going to multiply by a height because this is a 2D shape, not a 3D shape. And triangle should be on your reference sheet as well. 1/2 base height, or base times height divided by 2. So these are formulas that you do have to memorize, especially the square and the rectangle. The other two are given to you, though. And in our first example, we're talking about population of people in New York State, more specifically New York City. It says that we had the census. A census is a way to count people. So you fill out a form saying, yes, I am a person that lives in this county, so that they can figure out how many people we have in a particular area of the state. So they tell us that the population of New York City is estimated to be 8,175,133 people. So this is our P, the population. The land area of the city is figured to be 302.65 square miles. So that's the area. What is the population density of New York City to the nearest person? So we're going to say PD is equal to P over A, population over area. And we just plug in. We know that the population is 8,175,133 divided by the area of 302.65 square miles. So you're going to type that in your calculator, being very careful about what numbers you are actually typing in. And you're going to come up with an answer. Something like 27,011.8. But it says to the nearest person. I do not want 0.8 of a person. I'm going to even write myself a note. Can't have 0.8 of a person. That's so disgusting. I don't want a partial person. Okay, so we have to round. But there's not 27,012 people. We don't have quite that many people. So we do have to actually round down. I know that it seems weird because this 8 seems like it would move the 1 up, but we actually have to stick with 27,011 people. And this is per square mile. So for every 1 mile block, 1 mile, there are 27,000 people. Can you imagine that? Living in a city with 27,000 people in a 1 mile square? That's insane. That's too many people for me. Anyways, this is our answer. You do not have to put units, but I put it there so that you could understand what's happening. Okay, on the next page, we're going to see a Common Core question, and that's our last one. During an experiment, the same type of bacteria is grown in 2 Petri dishes. Petri dish A has a diameter of 51 millimeters. So this is the diameter down here. Let's just calculate the radius because we know we're probably going to need it anyways. Cut that in half and we get 25.5. And approximately 40,000 bacteria after 1 hour. So the population in this dish is 40,000. We have Petri dish B with a diameter of 75. So the radius, again, let's just calculate it, divide it by 2, is 37.5. And it has approximately 72,000 bacteria after 1 hour. So the population in this dish is 72,000. Determine and state which Petri dish has the greater population density of bacteria after the end of the first hour. Justify your response. So I'm going to split my paper up into dish A and dish B. In order to find population density, we have to have the population divided by the area. They gave us the population, but they did not give us the area. So the first step for both of these problems is to calculate the area. And it's a circle, so it's pi r squared. So I'm going to write that down for both of them. A equals pi r squared. And we're going to plug in. It's a good thing we found the radius, right? 25.5 squared times that pi. It does not say to leave it in terms of pi, so we're going to type the entire thing into the calculator. So we get A equals 2042.82. Okay, so pause your video, calculate your area for dish B. You should have found something like 4,417.86. Cool, so now we have the area for both. Now we're going to look and find the population density. PD equals pop over area. So I'm going to calculate it for the first one, then you can go back and calculate it for the second one on your own. Independence, yeah! All right, population of dish A was 40,000. And we're dividing it by the area, which we found was 2,042.82. So the population density for dish A, once I type it in the calculator, will be 19.5808. Okay, so we're going to keep that in mind, but it's not our final answer, because remember, we're trying to determine which dish has the greater population density, more bacteria per square millimeter. Okay, so pause your video, go over here and find population density for dish B. So when I calculate it, you can see that I did population divided by area, so 72,000 divided by 4,417.86, and I got 16.2975. So I'm going to squiggle that around there because that's important to me too. But now my final answer has to be about which one has the greater population density, which one has more bacteria per square millimeter. And that would be the one with the greater number. So in this case dish A is our winner. Woohoo, more bacteria, yeah. All right, so you could say dish A has the greater population density, but you don't have to explain. If it did ask you to explain, all you would do is say that it has the greater population density because the value is higher. 19.58 is larger than 16.29. Okay, so this is all you need to know about density and population density as far as this lesson goes. You do have to memorize these formulas. Maybe we need to write that down off to the side. Memorize density formulas. D equals M over V, and PD equals population divided by area. All right. If you have any questions, let us know. Don't forget to practice. You will need it before you go on to your CFU.